Well, again, thanks everybody for joining. Again, if you have any questions, please feel free to post them to the chat. This meeting is being recorded, as Stephanie mentioned. And without further ado, I'm going to turn it over to Sridhar. Please introduce yourself and lead us on.
Thank you so much, Brian, Aaron, and Steph. Good morning, good evening, good afternoon, everyone from joining from all parts of the world. It's a pleasure to talk to you on this occasion and share the knowledge that I have regarding MuleSoft. Very briefly, again, my name is Sridhar Yenamandra. I work as a director, platform architecture group in the Salesforce advisory divisions with an entity data INC. I lead the MuleSoft in North America region with this company. So I primarily work with MuleSoft, Salesforce integration, and Oracle, middleware, and a few other past technologies. Also a bit on AWS, and of course DevOps across all these, platforms and technologies. I've been kind of in IT for 16 years as a technical solutions architect. Also was in delivery leadership, and I'm in client advisory currently now. So I don't have too many certifications, but a few of them are AWS or solutions architecture. Oracle is something that I worked for a long, long time. So I have a few certifications in Oracle PaaS, on-premise, SOA suite, and all that, and a few of the mobile backend as a service certifications in Oracle. I'm a MuleSoft integration architect, MCIL level 1, MCPL level 1, a few other certifications as well in Java also. My key focus areas are enterprise architecture and strategy. That's what I do day in and day out with the clients. Also building the MuleSoft and Salesforce practice. I also work on the Salesforce integration. So I think pretty much that's it about me. Again, thank you again for this opportunity. It's a pleasure to kind of present something to you. This is my picture. This is my company's logo, and feel free to kind of connect me on LinkedIn for any future questions or in general connection. All right. Before we go into the presentation, a quick check. Brian, Aaron, can you hear me? Can you see me?
I can hear and see you just fine.
Excellent. Right. So a quick disclaimer. I've put some pictures in this presentation, obviously, to kind of have something interesting and not boring. So none of those pictures are mine, or do I have a copyright of, I just freely use them from the internet. So this is only for the learning purpose, not for marketing or anything. So that is one thing, and all the opinions are solely of mine and not my company's or anyone. So I could be wrong. I would appreciate if you could correct me, or if there are any questions, feel free to kind of express them. All right. So with respect to again, today's topic is Anypoint Service Mesh, and understanding what it is. Before we kind of understand what is Anypoint Service Mesh, we will talk about service mesh background. We will kind of try to understand, forget about the Anypoint Service Mesh. What is a service mesh first, and what leads to service mesh right first? And then we will dwell into the Anypoint Service Mesh concepts, features, and into the demo. All right. Are we all good to begin? Like Steph mentioned, I think everyone is muted, so I guess we don't need to repeat that. And if you have any questions, and any questions, feel kind of write them, and you can probably ask them when you get an opportunity. So that in parallel, I guess Aaron would be answering a few questions, but I think we'll have some time for question and answers in the end or also in between. All right. The first slide, the technical slide of today's presentation is service mesh background. So we'll just try to understand, what is service mesh, right? Even before we go there, we need to understand these three things for sure, because today microservices are built mostly on, Docker, or microservices are basically container oriented, and we need container orchestration, and we need service mesh as well. We'll look into them in the next slides. Okay, what is Docker? Or let's talk about containers in general, right? Even before we move to containers, we have virtual machines. We've been having virtual machines for a while now. They were a revolution some time back. They kind of provide the hardware virtualization. You don't need to have multiple machines to kind of host multiple applications. All of that could be virtualized into a single machine by using VMs. We've been using it. It's absolutely still going on very well, but there are some challenges with it, right? Like you need multiple operating systems. It adds a huge overhead on the memory and storage. And the apps that are deployed on the virtual machine are not really portable. It's like a common problem is it works on my machine, it doesn't work on your the other machine. This kind of a common thing that we kept hearing. And on top of it, hypervisor is something that converts the hardware, the operating system, the host operating system's hardware to the guest operating system. All this conversion is really a huge overhead. So there were too many problems to kind of have microservices pattern with VMs. So the world went on with and came up with a new technology called containers, right? So that's what you see. We have the container in between basically it's about the OS virtualization, right? You have the apps, all the apps in the same operating system without a hypervisor, which hugely kind of improves the performance. So a part of the bins and libs of the host operating system, it was initially on Linux, but now it is on Windows and I think Mac as well. But so part of the operating system's bin and libs are made as if like it is a small operating system and a place where app can live and its bins and libs can live. And in fact, they can share bins and libs because they're actually having the same storage, and the same operating system. It is pretty lightweight. It's kind of portable. The applications are really easy to be ported to other. You can move it to any other place, let it be public cloud or private cloud or on-premise. You can just move the containers anywhere, and they're pretty easy and they kind of are maintainable because it's the same container anywhere. So this is containers, right? So all of us know about it. I don't really want to go in deep about it, but I want to have the basics very stronger because it's pretty much important to kind of understand all these basic concepts even before we go into the service mesh. However, we have got a lot of challenges with containers, right? Containers have become so popular that popular companies like Netflix, or I think many companies use thousands, if not tens of thousands of containers, right, to run their applications. So this came up with a multitude of problems, the deployment of the containers, the management of containers, the scaling it out and in. And also the networking between the containers have been really, really difficult to manage or mostly being managed manually. So the world was looking for automation, right? Anyway, DevOps was coming in between in that time as well. So the world was looking for the automation and people felt extremely challenging to kind of manage these containers manually. That's when there is a need for container orchestration, right? And Kubernetes was kind of, Google came up with a concept called container orchestration. And by the way, Docker also have a container orchestration called Docker Swarm, but Kubernetes is more popular and more flexible, actually. Kubernetes is like, as I said, it's an open source container orchestration system for automating this deployment, scaling, and management of containers. So you basically have an orchestrator in between that provide an automated scheduling, self-healing capabilities, like the restarting the containers if something died. It's like all automatic. And then horizontal scaling, load balancing, all these features, right, that are required for the management of containers are kind of heavy lifted by Kubernetes. This is one of the most popular technology and the software that almost every single company today is using, especially if they're using microservices. Even if Docker is not there, they use Kubernetes for sure. So Kubernetes is a container orchestration system. Now, before we go into the next concept of services and service mesh and then Anypoint service mesh, I want to kind of touch base a bit on Kubernetes because Anypoint service mesh, the topic in the context is about microservices that are deployed to the Kubernetes. So in order to understand a few concepts of that service mesh and Anypoint service mesh, you need to understand a bit, if not a bit deeper in the Kubernetes. And this would be really, really helpful. These are all common. This is nothing related to the MuleSoft directly. So I hope, learn a lot from this benefit in general. So anyway, we have something called pod in Kubernetes. It's a group of, one or more containers. And those containers share the same, storage. They have their IP address, and they basically, those containers can have applications deployed within them. So a pod is a minimum single unit that Kubernetes kind of holds. It's called schedulable unit, or pod is the lowest level that Kubernetes works on. It can't do operations in the containers by itself. Pod takes care of it. So pod is, if you keep hearing this term pod, it basically came from Kubernetes, and it's a group of containers. Even before pod, actually, you should have node. A node is like a virtual, you can just think of a virtual server or that has CPU and memory, right? So it is a group of pods. It also have, these pods have, obviously, like I said, volume. They have application containers within them, which are based out of Docker, or probably, I think, apart from Docker, Kubernetes also supports another container system. I don't remember right on top of my head, but I think these are containers, the green ones, and they have applications within them. And all the circles are pods, right? This node will have a process called kubelet and Docker. These are to communicate, with the cluster. We'll understand, of course, Docker, but kubelet is something that helps communicate this node with other nodes as well, with the control plane, and you'll get to understand this. So a pod is group of containers. We've learned what containers are. A node is group of pods. At this moment, that is good enough. And now comes the word service, right? A service is, you can think it of an abstraction layer, right? Let's say you have a orders application, or you have an inventory, services and group of services. Group of microservices that form. You kind of want to make it as one service, right? And you want to kind of expose them to the external world, or probably to the local, across the cluster with other microservices. So if you want to expose any of your application, or in other words, called deployment, you have to kind of have a service front-ending that deployment. There are kind of 4 kinds of services. We'll go into, probably if I get a chance, we'll go in detail on that. But service is something which is like an abstraction layer on the pods, which hosts this kind of deployment, right? So it's basically something that helps you expose your deployment to the external world. You can just think that way. So for example, here service A is having its, the most important concept of service is, the pods, right? They can die. There could be many situations that pods can die, and you may lose this IP. You may lose this IP address. Let's say here it is 10.10.10.1, and let's say if you're some other service which wants to call this pod kind of refers to 10.10.10.1. Probably something bad happens, and this IP is not fixed. When the pod restarts, it may come with a new IP. So, however, the service, right, will have one IP address. It will never change. So this is again the local IP address within the system, but you may have an external IP as well if you expose it as a load balancer or a node port service. There are 2 kinds of services which can externally be exposed. So a service is abstraction on top of the the pod to kind of help the other services discover it in a uniform way, which is available all the time. So we understood pod, we understood node, we understood what is service. Now let's talk about let's look at all of those and together a bit here, right? So enter the Kubernetes cluster. A cluster is a group of like, as you know very well, right? Cluster is a group of nodes. As you can see here, there are like 4 nodes. The big ones are worker nodes. The center, the small one is a master node. So you basically have a master-slave architecture, and you have the master controlling the worker nodes, the slave nodes, and the slave nodes are the ones that actually provide you the application. They are the ones that host the pods and the containers and the applications and services. Master is taking care of the cluster management and few other common cluster facilities, right? So it's just a master-slave architecture. You have nodes, you have a master node, you have a slave node, you have deployments within the worker nodes, and you also you also have few other cluster services given by the master. This is just a view without really giving all the components of the cluster, but this is what the Kubernetes cluster looks like with most of the components listed up there. So again, I mean, both these pictures supposed to be the same, but this is one view. This is like a another view of it. This is called basically the Kubernetes cluster architecture. You have the master node, you have worker node. You will have multiple worker nodes. Within worker nodes, we have pods. Within pods, we have containers. And for the containers, we can use Docker. We are talking about all of this. We have 2 other things, right, within worker nodes. This is called kubeproxy, and we have kubelet. Kubelet is simply an agent that communicates with the master node through the API server. So API server in the master node is something like, let's say if you want to use a command line interface or a dashboard or a UI that is if you install Kubernetes locally or even in the Google, you have a dashboard, right? All those communication happen through APIs, right? And the API server provides all those Kubernetes related APIs. And the same way, in fact, worker nodes also connect through the APIs using kubelet. We have scheduler in order to schedule the pods or containers into the pods. If some pods die, it needs to know when to schedule it, when to unschedule them. We have many other components in the master node, which would take a lot of time to discuss, but this all takes care of the cluster management, right? And we have the kubeproxy that basically is like you can say we have seen service, right? Let's say this is the container has applications, right? And let's say a hello world application, and we need to have a service in order for it to be accessible from other services, right? Kubeproxy helps you do that, right? It's basically a network proxy. It does it has some network rules, but it is like you can think of it as a service, right? A kubeproxy is basically called by the service, which does more filtering and logic for routing, which in turn actually calls your application in the containers. So there are a lot of other services like ingress controller, kube services, etcd is a key value store. These are like load balancers, a few other services that provide access from the internet to the worker node. All right. So this is a cluster architecture. Very quickly, we need to talk ideally about for a lot of time on this, but given the time constraints, this is about the cluster architecture. So again, we've talked about Docker, we have talked about Kubernetes, we are kind of going into the Kubernetes cluster architecture, we have talked about services, right? Now, just take a slight step back. With all this present, right, even with all this Kubernetes, cluster management, container orchestration and all, there are a lot of challenges still. One of the primary challenges with microservices using all this technology still is still the containers need to do still a lot of stuff like service discovery, load balancing, resiliency, like you can have policies that make services resilient, right? Or mechanisms like fault tolerance mechanisms like circuit breaker, or routing mechanisms like you want to kind of send 90% of the traffic to one service and 10% of the traffic to another service. These kind of mechanisms are still handled by the service itself, and this is getting kind of very difficult for each service to kind of do the same thing in their own way, leading to inconsistencies. Now, that's where service mesh concept has come into the picture. This is very important because this is a key thing that we are kind of, most important fundamental concept before we go into the Anypoint service mesh. So before service mesh, we have, sorry for the picture got cut, but basically it's mostly it is good. We have the operation code that basically describes the service. The business logic that describes the service, and operations, operational code, which is basically doing all this. And you need to kind of do it on every service. But service mesh kind of generalize that. It basically, you will have another kind of something called sidecar proxy. Remember this word, sidecar proxy? It's just like a agent sitting on each service along with its business logic. And it gets controlled using a control plane, right? Let's say you'll have a single control plane. You'll say, I need to have this traffic policy for this service and in this situation. It automatically updates, that to the agent and probably all the agents, and you'll get that feature simply available. So you will have a uniformity in controlling all this feature for the services. So let's see what exactly are those features, right? This slide is a bit heavy, but just take a look at it. So these are the features that service mesh provides. It provides discovery, it provides routing, it provides security, like mutual TLS between the services, and it provides observability, like monitoring metrics, and all that. It also provides actually the resiliency, the fault tolerance, false recovery, and many other operational aspects of the A/B testing, canary rollouts, and few other policies. So you must be thinking, we have heard some things like this in simple Kubernetes as well, but or probably. You have heard this in the API management, right? In MuleSoft, we can apply policies. We do all these things, right? So that is true. A part of that in Kubernetes is being done by service mesh, and there are a lot of tools to enable the service mesh, like Istio, which we are going to talk about. But you understand one thing here is there is a difference between north-south traffic and east-west traffic. If you see east-west traffic, this is all east-west traffic, which basically means a traffic between services within a Kubernetes cluster, right? Within the on-premise or Google Cloud or wherever the Kubernetes cluster is, it is between service to service. The green represents the logic for the service or the business logic, and the blue represents the service mesh, proxy that actually carries that operational logic, which this talks to the service next to this, talks to the service next to this, and so on and so forth. This is called east-west traffic. The north-south traffic is if a user is coming from an external, if any of the services exposed externally, right? And let's say a user or an API gateway is calling that service, that is called north-south traffic. So we'll touch base upon this, in a few slides. But remember, a service mesh is an east-west traffic, and it is implemented using sidecar pattern, sidecar proxy, or a sidecar proxy design pattern. All right, we'll not touch too much on the Istio. Let me quickly check the time. Around 15 minutes, I guess. So we are good. So Istio is an open source service mesh. So like how Docker is providing containers, Kubernetes is providing container orchestration, Istio provides service mesh. So, and like we already have seen the pattern, right? You have the service logic, and this is sidecar proxy. This is mesh traffic. Remember, the mesh traffic is different to the outside traffic. The mesh traffic is considered to be east-west. The traffic or the calls from external world into or outside will be considered as north-south. So you have the Istio control plane to exactly like I was saying, right? The service mesh will have a control plane where you kind of control all these policies or service discoverability or all these features that we talked in the previous slide. So that is done by the control plane. So this is Istio. Istio is kind of just an implementer of service mesh, and it lets you provide all the service mesh features like connecting, securing, observing services. All right. Any questions at this moment, Aaron? Do you see any questions? So this is a time to ask questions before we move on further.
Don't see any in the chat. And just as a reminder for everyone, don't hesitate to put questions in the chat if you have them. Oh, actually, we just got one. Let's take this one. So Ravi asked, is all sidecars, can they be viewed or managed from the UI?
Yes, the sidecars, can they be viewed? I'm not sure, but obviously they can be managed, and that's the reason for having the control plane. So the sidecars are nothing but, you can call them as a proxies as well. They will hold some logic to talk to the service, right? Rather than the service talking to the service, the proxy talks to the service, and this proxy, which is nothing but the sidecar, is being managed by the control plane. For, let's say, providing mutual TLS, you just will have something like Anypoint platform, right? What we have, we manage the Mule services, for example, by applying policies or doing load balancing or whatever, right? So same way they have a control plane, and the control plane controls a sidecar proxies. Whether they can be viewed, I need to kind of, I'm not really 100% sure when you say whether we can do a CLI view for a proxy or not. I'll have to get back to you on that.
Great. Yeah, two others actually. So service mesh works in the Anypoint platform architecture is one of the questions.
I didn't understand that. Can you say that again?
The question from Irving is service mesh works in Anypoint platform architecture. And I think what Irving means is service mesh incorporated into the Anypoint platform offering, which is, short answer would be yes. And, Sridhar, not sure if you want to expand on that.
All right. Well, part of this question, honestly, all right. So if I understand your intention of this question correctly, does MuleSoft provide service mesh, right? We'll talk about it. Obviously, that's the topic of the day. Anypoint service mesh is a MuleSoft service mesh from, quotes according to them. So we'll talk about Anypoint service mesh. What is it? Really, does it provide service mesh features? We'll definitely talk about it. We'll touch base in the next slides. Next question, Aaron.
Okay, can you describe the difference between a service and a pod?
Okay. Let me go back to the slide, right? So this is a good slide to say. So a service is, like I said, a pod. If you have a pod, which is group of containers, right? Providing a particular feature, let's say an inventory, accessing inventory or creating some CRUD inventory, let's say, right? Which in turn talks to the backend system. Let's say it's ERP system or a database, right? Now you have a pod, which is a single schedulable unit by Kubernetes. All of us understood what it is. But one needs to understand that this pod is not permanent. It basically kind of, like I explained before, you will lose the pod. I mean, let's say if something happened within your Kubernetes cluster, some pod died because of some error that rolled up to the pod level, and pods can die. And and probably this inventory service is being called from the order service from another pod, right? Let's say that is not how it is going to happen. Let's say if pods talk to each other, the entire system is going to fail, because you need to kind of, if you call a pod with an IP address, you will not get the IP address back. These IP addresses, just like, the Kubernetes gives another IP address to the pod. That's where service is like an abstraction on top of the pods, right? To enable that exposure to the other services, right? In addition to the exposure, it also provides a bit of load balancing. Again, it gets confusing because service mesh also provides load balancing. Kubernetes cluster also provides load balancing. So leave that point for the time being, but the service provides the exposure to the other services. So there is a fine difference between pod and a service. A service is an interface to a pod. And it could be sometimes a group of pods, right? That's totally, you can have a entire, let's say, inventory service. You can have probably some other service and few other service grouped as a service, right? One single service, which actually share the same IP, and a few other details, right? So a service could be a group of pods, and it is an abstraction over the pod.
Thanks, Sridhar. I'm going to put here in the chat, I'm just inventorying the questions, and we can go ahead and move ahead, and we'll get to the rest of the questions later.
Thank you, Aaron. Thank you. So we'll move on with the next, it's time for the first trivia question. Let me go back. Aaron, so I just want to kind of show the trivia question so that people can answer. Do you want to say the rules to them? Because I think I just went to the next slide.
Yeah, I don't think we mentioned that at the beginning. So we do have an exam voucher giveaway for the winner of these trivia questions. So the first correct answer in the chat to Sridhar's trivia questions will get an exam voucher, and that's good for one MuleSoft certification exam. So get ready with your chat and to answer these trivia questions.
Thank you, Aaron. With that, in next 5 seconds, I'm going to the first question. So be ready, hands on your keyboard. Do not rush. You may get the answer wrong. So here you go. Select the right option from the below. From what you have just heard, what is correct? Is it A, B, C, or D? Only one option is right here, obviously.
I think almost everyone has answered at this point. If you want to go ahead and explain, I'll scroll back through the list because quite a few came in at a time. But go ahead and explain the answer, and I'll identify the winner.
Sure. So thank you, Aaron. Obviously, the Docker is a tool for running containers. Kubernetes for container orchestration. Istio is an open source service mesh, right? So the answer is D, which is this. Container orchestration and service mesh.
Good job. That's Robbie Sa. Looks like you won. So Robbie, we're taking down your name. And actually, if you could put your email address in the chat here, we'll take that down and email you the form to get your voucher.
Congrats, Ravi. With that, we'll move on to the next part of our the presentation. All right. So at this point, we understood what is Docker. We understood what is Kubernetes. We understood, at least to a certain extent, what is Istio, right? They provide container. They do the orchestration. And Istio provides a mesh feature over there's Kubernetes-based Docker, probably applications to have east-west traffic and any interactions between each of them. And congratulations, that's the minimum thing that you need to know before you even understand what is Anypoint service mesh, because the key part of Anypoint service mesh. Leaving the Anypoint is service mesh. So you need to understand what a service mesh is even before you go in there. So this is good. Let's try to see what exactly now MuleSoft wanted to do. As you know, MuleSoft, right? The application network in the MuleSoft, they want to kind of connect all these backend systems or the enterprise systems or the public, all the cloud systems of an enterprise, right? They want to make a mesh using the API-led connectivity. They want to have them connected so that it forms an application network, or similar to the mesh, right? The service talking to another service, well connected, so that tomorrow if a new requirement comes in, you put in a small new process API or probably a system API and connect it to the network. That forms the application network, and it keeps on expanding. And this is one of the greatest concepts. Again, this is there is no specific thing like an application network on the system. This is virtual thought. As long as you follow API-led connectivity in MuleSoft in the right way, following all the principles, it will form an application network over the period of time. So that's something we've been hearing on, right, for a long time. So by the way, we are entering from the MuleSoft point of view in this presentation only now. Till now, what we heard is all the generic concepts, right? So application network. Now, obviously, you have the non-Mule microservices. We have just discussed about Docker, Kubernetes, and Istio, and a service mesh, using Istio. So there are a lot of microservices deployed using in the Kubernetes cluster. All this is in the Kubernetes cluster, and they are not connected to this network. And MuleSoft thought, oh, why not? We have a lot of customers using Kubernetes, and Kubernetes is anyway a very popular system. Why can't we connect them? Is there a way that we can think to connect them to this application network? And when I say connecting to the application network, that means that it is discoverable using Anypoint. It is manageable using Anypoint Manager, right? It is explorable using monitoring analytics. So whatever you can do with your Mule services, right? Mule API. Can we do the same thing with non-Mule APIs as well? Is the first thing they have thought. Now, well, some of you must be thinking, this is nothing new. I mean, if the non-Mule services are exposed using a public IP address or a public DNS, right? Right. You don't need to do anything. Today we have API Manager, API proxies. If you create an API proxy in the API Manager with the endpoint with proxy, you create an API proxy. You can always give the implementation URI and provide that implementation URI. You don't need service mesh. You don't need anything. Just the API Manager proxy. And as long as you have that URI of the backend service, let it be anywhere in the world. And as long as you follow the security, authentication and all that, you can simply call the proxy. Simply call that particular service from the API proxy as it is today. But that's not what MuleSoft wanted to do, because that's already available. What it wanted to do is, there are many customers out there who are having their services, microservices, deployed to the Kubernetes cluster, and probably using Google Kubernetes cluster, or in the Google Cloud, or Azure Cloud, Microsoft's Azure Cloud, or probably the AWS Azure Cloud. And those services are lying in the Kubernetes cluster, but they're not exposed to the public. They're not supposed to be exposed to the public. Maybe they are services for internal communication, right? For maybe only there will be front-end services, front-end UIs, only some of them, right, which will be exposed. But a lot of them are not exposed. So in that cases, how do we kind of provide the service features to them, like policy management? How can I discover those services? The whole point is about discovering them in the Anypoint. So they want to make Anypoint Exchange as a common platform to discover the services. And they want to make API Manager as a common platform to manage the services. And when I say manage the services, policy management and all that, right? So how can I do that? When this non-Mule microservices does not have or are not exposed externally. So I can't use API proxy. That is when you, so, okay, that is what basically, is the introduction of Anypoint service mesh. So you need, I'll go to the next slide, but just wanted to kind of give you this important concept. You need an API, just like what you see here. I just expanded, this is nothing special. You need an API that needs to be connected to a microservices, which is not exposed to the public, right? And these services, once you apply policies, they should be visible within Exchange. And when they kind of communicate with each other, the policies that you apply on this API should be kind of, applicable when they communicate with the services internally, right? That's where you need a connectivity to those internal services, which is done by Anypoint service mesh. So that actually, it's in other words, it's trying to kind of expand its application network. All right, a bit of text taken from the MuleSoft documentation, but I'll just say don't focus on it, don't read through it. That's a usual tendency. We kind of keep reading when a new slide comes. Don't read this at all. So Anypoint service mesh is a new feature, very new feature, which is probably released late last year, I guess, somewhere in November. I'm not really sure on the timing, but it is definitely new. The idea is to bring the non-Mule microservices into the application network or into the Anypoint Exchange or into the API management so that we can control them and kind of provide that east-west traffic management, east-west service discovery. We are not talking about north-south. That is exactly what I was trying to highlight. North-south comes into the picture only when you have these services externally available. That is when you get into the API gateway. That is when these services are something one company is calling. Let's say if from entity data, I'll call a Google's service. That is north-south. That is not going to be east-west. But within entity data, I call a service in another LOB or another department, but it is within internal. That's called east-west. So Anypoint service mesh is for the east-west communication, which is basically done by the sidecar proxy. So it basically is to extend your non-Mule microservices into the Anypoint platform sphere, and it extends those our API management capabilities into those non-Mule services. Nothing more than that. Just to conceptualize, to have a view of how does it look like, right? So we talked about everything that we are seeing in this picture. Leave the Anypoint runtime fabric for the time being. So this is a Kubernetes cluster we have seen. This gray things here are kind of nodes and pods. You have the service logic. You have the sidecar proxy. So this is obviously the service mesh pattern, and you see this blue thing. That is what MuleSoft wants to kind of provide. So the question is probably lingering in your minds if you have followed properly is, Sridhar, come on. Istio already does this. Istio is a service mesh which already does this, service mesh management. What is Anypoint platform doing? Is it really providing a service mesh? Well, Anypoint service mesh is just connecting Anypoint platform to the Istio of the Kubernetes cluster. If you apply, which basically means if you apply a policy here, you are applying a policy on the Istio. And Istio is actually dealing how to execute the policy inside this Kubernetes cluster for these services. So basically, Anypoint platform is not doing anything apart from just connecting to Istio. It is not taking care of the service mesh capabilities, but it is connecting to the Kubernetes service mesh. All right, that's something that I want to kind of highlight very, very strongly, which is one of the key things of this particular presentation of this product. Now I'll move on quickly. I spent a lot of time in making you understand this, but Give me just 10-15 seconds of a break. All right. Sorry for that. How does Anypoint platform connect to Istio? Is something called Mixer or a Mule adapter. Mule adapter, I mean, like you can see, right? This is an agent, right? Sitting inside Istio that talks to Anypoint or listens from Anypoint and forwards the calls, nothing else. So Mixer is we'll talk about it. Mixer is a concept or a technology that provides that general plugin feature where Mule is one of those plugins. If you want to talk to Google, you could have another plugin. If you want to talk to AWS, that you could have another plugin. So this is nothing but a Mule plugin that internally talks to Anypoint platform, right, of Mule. You can have other plugins as well. And Mixer is kind of a generic, plugin architecture that provides constructs to kind of create those plugins and connect those plugins without knowing the underlying features, right, of the service mesh, of how Istio manages the service mesh. This Mixer provides you those interfaces for those adapters to connect to the external systems, to the service mesh. All right, very, very quickly, 10 seconds. This is how the call goes right here. Let's say someone, let it be another service or a client, is calling, wants to call a microservice, right, through a browser or through a service or whatever. So they try to call microservice, but there is something called envoy. You don't need to really know this. It's just a validation or a precondition checks and telemetry reporting. It basically does some telemetry reporting. In order to get the analytics of how many people are calling what service, what kind of things are happening. It also does some kind of validation for a microservice, so you can just simply forget about it. So the client calls in order to reach the microservice. The one is the first step. The sixth is, this is not the second step, obviously. So what I'm saying is they can't reach the microservice directly. And why looks into it? Oh, do I have any policies? Do I need to kind of forward this to Istio or any other adapter? Is there any policy applied? So it'll check and it'll forward. It'll call Mixer, and Mixer, obviously within the Mixer you have Mule adapter, and it gets information that we have a Mule binding or an API that is bound to this particular microservice through the Mule adapter. So it understands that, and then it gets those policies from the Anypoint platform, which are defined there, and kind of applies those policies using Istio. And then after application of policies, call the microservice. Okay, that's how the flow goes, right? In order for a client, we will see this. We'll actually see this. I have a demo for this. We'll understand all these concepts. But what you need to understand is you have a microservice. In order for a client to reach a microservice, it doesn't go directly. It goes to the Mule adapter, which checks if there are any policies in the Anypoint platform. As I said, Mule adapter is just like an agent or a plugin within the Mixer. And if you have a policies, it gets those policies and kind of applies on the microservice, and the client can call the microservice. All right, it's time for the question 2. And this one is not going to be easy, and it could take time. So, Aaron, I think I need something around 25 minutes. Are we short of time or are we good on time?
No, you just keep right on going. We're good.
All right, so question 2. We'll spend 3 minutes here. I'll let you read rather than interrupt you.
And just to be clear, there's 2 answers on this one. This is a multi-select.
Yeah, the 2 answers. It's just not one. AB, AC, AD, BC, CD, like that.
I believe we just got the correct answer. Coming in fast again.
Oh, wow.
maybe give it just one more second, then you can go ahead and explain.
Kind of. Sure. But curious to know who it is.
Every time somebody chats, it brings me back down to the bottom, which is fun about this tool. Looks like it was Ravi Tamada this time.
Oh yeah, I know him. So I'm kind of sure he would answer this. Ravi, probably you know about Anypoint Service Mesh even before. But if you kind of answered this question right with this, only now learning from this presentation, I'm pretty happy. Very good. Congratulations. All right, we'll move on. We're slightly going short on time. There's a lot of things to show, and I want to cover a good demo and show the Kubernetes cluster and all that. So the answer is, let me read the question once again. What are the two product options provided below that they should consider suggesting? So the answer is Anypoint Runtime Fabric and Kubernetes cluster installed on premises. So basically, you have Mule service and non-Mule services, and which should be deployed into Kubernetes. That's about these 3 lines. Mule, non-Mule, into Kubernetes. Now, what are the options that you want to suggest? The next 2 statements just say, what should you suggest out of this 4? Then we think, service mesh, you can actually pick anything. But there is a note that says you cannot have microservices in a cloud. Okay, so they should be only locally deployed locally. So in order to have that, service mesh does not work. You need to have. You can use Anypoint Service Mesh only if it is deployed to Google Cloud, Microsoft Azure, or AWS. I just told this a few minutes back. So you can't use Anypoint Service Mesh. You use Anypoint Runtime Fabric because you have Mule microservices in the Kubernetes. Nothing else provides apart from Anypoint Runtime Fabric. The Kubernetes-based Mule services managed by MuleSoft. And you can do that using Kubernetes cluster installed on premises as well, right? So these are the 2 options, A and C. All right, I have another question coming up. Be ready for the next question. 3, 2, 1, go. This is simple. And you have only one answer. I just gave this picture to pick. You can pick from one of these. Aaron, you must be getting answers.
I'm trying to scroll back to the top. I saw it come in. Akshay. Yep. Akshay got it right.
So, right. Wonderful. Wonderful. The answer is obviously the sidecar pattern. We have focused on it and we have talked about it a lot, which basically does the east-west traffic, and that's what service mesh is used for. It's not for the north-south, where API gateway and API proxy with the proxy endpoint, right? The implementation URI takes care of it. All right, we're pretty close to the demo. But before we demo, right, I want to kind of show you the provisioning steps. So basically, how do you install, download, or how do you provision Anypoint Service Mesh? Where do you provision it? So there are 4 steps to it. I've just put this in a form of a presentable slide. These are pretty much available and obviously in the documentation, but you will not find any blog or any YouTube video or anything apart from that, and it is not easy. So if you follow what I'm going to say, it is going to be very, very easy. It took a lot of deal for me to kind of figure this out myself just with the documentation, because there are many things that are not given in the documentation directly, which I need to explore and figure it out by myself. So this is 4 steps. You have some prerequisites, which basically is you need to work with your partner manager to get a trial license. Once you talk to your partner manager, they reach to MuleSoft, they will give you a trial license, and they will provide those entitlements of service mesh into your Anypoint platform. Before that get done, there is no point in you going further, because you'll simply get an error in one of the steps when you execute one of the steps saying license required. You don't have sufficient entitlements to kind of install Anypoint service mesh. You will have a hard block there, and for that you need to get a trial license, or you need to get those entitlements enabled. You need to, if you're using Google Cloud or whatever cloud, like any of these three clouds, right? You don't have obviously the service mesh feature on any other clouds apart from these three at this moment, or even any other way, right? Not even on the on-premise. You can't connect to the on-premise Kubernetes cluster using Anypoint service mesh. So let's say you use Google Cloud, which is what I'm going to show in the demo. You'll need to have, there is no prerequisite mentioned that you need to have at least 2 nodes. I was initially trying with 1 node because I don't want this, I don't want to spend any money on the Google Cloud. So I thought, let's try with 1 node. But there is a prerequisite saying you need to have at least 4 CPU and 8 GB of memory. That's a prerequisite. I mentioned 16, I'll say why. But that is what, the Anypoint service mesh documentation provide, 4 CPU and 8 GB of memory. However, I would say, first of all, you can't have a 4 CPU and 8 GB memory in Google Cloud unless you go with custom and all. If you take some of the standard, standard machine E2 standard, I think standard compute engine template, right? You will have to go with this 4 CPU and 16 GB memory. And in fact, 4 CPU is not sufficient. I've got a CPU CPU error. It says that, insufficient CPU. And just when I install Istio, when I install service mesh, all installations are done. There are so many pods and CPUs being utilized in such a way that all 4 CPUs taken. So I then made it 2 nodes so that, I'll have 8 CPU and 32 GB of memory. That's when I could, in fact, go on, proceed ahead with some installation of some, or deploy some application like a Hello World application. So I would suggest, I know I'm spending a lot of time here, but these are the 2 key points. Go with, if you're going and trying to experiment this in Google Cloud, go with 2 nodes of each 4 CPU and 16 GB. You'll see this in the coming slides. I'm going to show you all that. All right, from there on, it's going to be fast. You'll have to, with this prerequisites, right, you can install Istio, either Istio 1.4 or 1.5. You can see all this in the documentation. And obviously, you need to get, client ID and client secret of your platform. For that, you need to have organization administration access. Sorry for that. So once your prerequisites are done, you're going to download and install Anypoint service mesh, right? And which basically is, is installing the service mesh and also installing Mule adapter. We have talked about, right, that Mule adapter, which was sitting in the mixture, which is like an agent. We have also seen that in the previous steps in the service flow, which basically interacts with Anypoint exchange. That is what you need to do. The third step is to kind of configure. Now, when I say configure, first identify, you need to, this is not a mandatory step, but obviously if you're doing something from the beginning, you have created a Kubernetes cluster, you have installed, download ASM and, Istio and all that, but you don't have any, application in your containers, right? What are you going to kind of talk to from your API? So I just created a sample Hello Node service, which is a Node.js service. I'll show you that again in the Kubernetes cluster. I created an API in the Anypoint platform, in the API manager, and then I've got the API ID. And using a command, I could bind this API in the Anypoint platform to this particular service in the Kubernetes cluster. The word service, so specifically I'm mentioning here because that is actually the service that we talked about. Because a service, a deployment, or a pod cannot, you can be only talk to another, any other external word or even other services only through a service in Kubernetes cluster. So the first step gives service. The second step is an API, and you bind them. That is through the Mule adapter. You bind them, and then you're ready to talk. And then manage APIs, right? Now that you can see this in Anypoint Exchange, and also API Manager, you can kind of apply policies. You can, view analytics and all that. So these are the 4 steps, and the first 3 steps more specifically to provision, install the Anypoint Service Mesh. We look at it. Obviously, this would take a lot of time to do, so I can't do it now. Obviously, this would take 2 or 3 hours if I have to start from the scratch. But I did start from the scratch just today morning. I think yesterday morning, and I could provision this and could experiment a bit. So let's go to the demo. I hope you all are waiting for this. It's going to be interesting for sure. It is 7:08 time now in Denver. So I think I'll take 10 to 15 minutes for this, leaving 5 to 10 minutes for the final closure. Okay. So we are still good. So the demo scenario is like this. You have a web browser. You can think it as a browser service or a client or another web service or whatever. But for the time being, we'll just use a web browser. Calling a service exposed in a specific port. Okay. This is your Kubernetes cluster. So you can just think like, I'm just simply entering this, which is, nothing but a hello world app exposed to this external IP. Okay. And behind the scenes, this, okay, at this moment, let's say, it has not bound. So when I call that, you'll get this response. This is something that I just took from my browser, took a snapshot, and I just showed this is exactly what you're going to do. See, I just exposed a Node.js application, which is nothing but hello world, into a port 8080. So the port here is 8080. However, the browser is obviously 80. Okay. So this load balancer is kind of port forwarding it. The Kubernetes cluster is port forwarding it from 8080 to 80. This is just like the load balancer, external load balancer thing. So that's how it works. So if you don't do anything, it just keeps on happening. You hit like 5 times, 6 times, 10 times, it keeps on showing hello world because there is no rule or a restriction or a policy to it. That's normal. That's just Kubernetes. There is no MuleSoft here. Now, MuleSoft wanted to kind of connect this particular hello world application. So I created a Mule API, and then I bound this with this service, right? Using this green thing is the Mule adapter. Okay, so I created an API, and I bound this API with the hello world using the Mule adapter, and I applied, let's say, rate limiting policy. Maybe you can say 10 requests or 2 requests per minute on this particular service. We'll liquidate, and when you do that, you'll get too many requests, obviously, right? That's exactly what we expected. If you make calls more than what is given in the policy, you'll get this too many requests error. Now I can apply a few other policies like basic authentication policy, and let's say if I make the call again to this without passing any authentication details, I'll obviously get an error, unauthorized. Sounds good? This exactly is in line with what we were talking before. The reason why I want to show this picture is that you'll understand this is exactly what I'm going to do, and you'll understand. You'll understand, the flow of the demo. All right, let's move on with the demo. Sorry for that. Yeah. Aaron, quick confirmation. Can you see my browser?
Yeah, we can see the IP address starting in 3.5.
Yep. So I'm just entering here. Right. I don't know why this is not working, but let's see. Maybe let me check the cluster. This will 100% work. There's no doubt about it, but I'm just thinking maybe, yeah, everything's up. Okay, let's try to use Postman. I just want to make sure that I don't have the headers body. Yeah, okay. All right. Just want to delete this authorization and everything. So with just calling this service, let me try to send. Oh, okay. That's what. So let me take out these things. Let me go to the Anypoint platform. I already have policies applied on it. So let me go there and kind of delete the policies. I'm just logging into the Anypoint platform of my company, provided by my company. So obviously I have the entitlements at this moment. So the sample API, okay, let me show you the proper path. I just named it as a sample API, and you'll clearly see how I bound it very, very soon. Let's go to the API manager. And what do we do? Like I said, we will have an API, which is this sample API that I created just yesterday. I have created a version. It is active. You see this API ID. This is what I bound with the service in the Kubernetes. Okay, I'll show you how I did that. But let's see one thing. Let's go to the policies here. Right, I applied 2 policies. Let me disable them. That's the beauty of I love this feature of enabling and disabling so easily. It's really, really cool. Let me disable both these policies. Give it 30 seconds. It will take 30 seconds, and my throat is dried up. I'll just drink water and come back in 30 seconds.
I have a few questions inventoried, so don't worry. We're going to get to those at the end, right after this demo.
Right, I'm back. Again, I appreciate you for that. It's been a long day. Couldn't hold on to drink water. So let me be quick. So the policies must be applied now. So let's see and simply try to send. Yep, as you can see, hello world. I'll send many times, 3rd time, 4th time, 5th time, 6th time, 7th time, 8th time, numerous times. You'll get hello world. Correct? So now what I'll do is, remember, this service is absolutely, it's a Kubernetes service, okay? So it's not a MuleSoft based service. I'll show you, this is totally a Node.js service. We are not using runtime fabric. We are not using API proxy. We are using service mesh here. Okay, I'll show you that. Now let's enable the rate limiting policy. Again, this will take 30 seconds. I want to kind of wait, but I want to use this 30 seconds to show you one thing. Or else let me finish this. So I'm not doing anything else. Now I'm sending it again. Oh, by the way, I want to show you the detail of this, right? So I've set 2 requests in 1 minute. If I make a 3rd request, it's going to be in that minute, it's going to kind of show an error. So I think this is 2nd request. And now I guess, okay, the 3rd request, probably, let's see. Okay, either it is taking time or it is enabled. It is taking time, nothing else. I mean, I mean, it'll work because I worked on it for 100 times, so it is going to work. It's just taking time. 1, 2. All right, you see this? So it just takes 1 to 2 minutes sometimes. That's a problem. So too many requests. Now you don't get. Let's look into the header, right? And unfortunately, I'm not able to get that X rate limits and those things. But if you see this is nothing but a binary 64. So I thought of kind of decoding using this decoder, right, online facility. And when I just put that, it clearly says violation basic rate limiting, and hence it is blocked. Sounds good? So this is one thing, small, we applied the policy. Let me again take the policy back. Obviously it is going to work, right? It'll take some time, but this time what I'll do is, before I do that, I'll apply and enable the second policy, let's say the authentication policy. And what I gave is, it's a simple basic authentication, right? Username and password. The username is MuleSoft and the password is awesome. Okay, so I'm going to just give that. Let's see. And let me first enable this. Again, it takes 1 or 2 minutes. Losing time there, but let's see what I can do. Where am I? Yeah, I need to go to the postman. So I want to enter provide an authorization. Right here, basic authorization is selected. I'll say MuleSoft. Oh, I'm sorry, I'm providing the authorization. Let me call, before that, so that I want to see that error. I'll give it 30 seconds more. Yep, you see, I just clicked. It says 401 unauthorized. And I go here and I copy this. And I just found this as one of the ways to figure out what it is. Copy this, kind of go here, paste it, kind of understand or decode this message. Let's see what it says. Basic authentication, violation, blocked. So what did we see? We just saw this. We made a call to this. This is service within the Kubernetes cluster, the Node.js app. And we have a policy. We are controlling that with policies. We saw when we apply this policy, it is applying. When we take out the policy, it is not working. So we can control this hello world using the Anypoint service mesh. Now, I need 5 more minutes to kind of go through this cluster. This is very, very important for you to understand, right? So what happened behind the scenes, you understood. You also saw the demo. But I want to show you the Google Cloud of how I set it up. Wonderful. So this is my console.cloud.google.com. And in that, you go to Kubernetes engine. Over here, you see clusters. Click on the clusters, and you land up here. I just created a cluster. Simply create a cluster. Right. I'm just trying to show you how you can, right from the scratch, how you can create a Google Kubernetes cluster. Right. I clicked on create cluster. You can just name the cluster, leave the rest as it is, and go to the default pool and click on nodes. Don't create. And in the nodes, like I said, you choose the machine type. I was not getting this word. And obviously, you need something more than 4 GB, 4 CPU and 8 GB. So select this, right? This is 4 CPU and 16 GB. So select this, and you want to select the number of nodes somewhere. Leave everything as it is, right? Leave everything as it is, and you probably want to select the number of nodes. I think that was in the previous. Yeah, the number of nodes are 3 here. Select the default pool. Leave everything as it is. I named it as a Sri node pool or whatever. I'll show you all that. But leave everything as it is. I didn't enable auto scaling. I, in fact, took out these 2 as well because I don't want any of my money to be spent here. I don't want to auto upgrade because this is only for the demo purposes. I made the number of nodes 2. Initially, I was doing 1, but I got a CPU error. So I later scaled it dynamically, which is the greatest thing. Else, instead of dropping the cluster, just to increase the nodes, I scaled the nodes to 2. Again, remember, this nodes is nothing but the nodes that we saw, right? In the first thing, they are this is let me quickly show you that, right? What is a node here? This hexagons are nodes. Not talking about the pods or not even the deployments, right? So I chose nodes. You can think this as a machine, virtual machine, right? Within the Google Kubernetes cluster, Google Compute Engine. which these nodes are like worker nodes, which are a part of this cluster, right? So that's what I'm talking. So just go do that, leave everything, rest everything, and let's say create. When you create, you get something like this, right? I created the cluster, like I showed you, 2 in the location US Central 1, 8 CPUs and 32 GB. I've got this cluster. So I can, I want to kind of show the, I want to connect to this. You just click on connect and run in a Cloud Shell. Cloud Shell in Google is like a local system that is, or a CLI that is, is a different system from the Kubernetes cluster, right? Obviously, Kubernetes cluster has provided nodes where it has installed Kubernetes and installed Istio and all that. But Google Cloud is a way for us to kind of log into the Kubernetes, right? So first thing is, let's try to connect. And I want to say run in the Cloud Shell. Why doesn't it copy here? Let me manually copy this. From this, sorry for that. From this, if something wrong has happened. Control is not working. How do I get there? Connect. Run in Cloud Shell. The Cloud Shell is starting. Okay, you see, last time I don't know why it didn't show up. So I enter this. So now what it is happening is from my Cloud Shell, all kubectl commands will execute in this cluster. So I just got connected to this cluster from this Cloud Shell. So I'm in, if I say, I want to kind of show you, kubectl is a command, right? Like is a CLI command for Kubernetes cluster, kube control, that I can run on the master or a Kubernetes cluster. Now I want to show you what all do I have. I'll say get, what are the first thing? I showed you the cluster config, but let's say we'll try to say get nodes. Let me expand this. You see how many nodes? We have provided 2 of them. And these are these 2. Okay. They are from the node pool. And this is the exact name of the nodes. They're ready. The age is 43 hours, one, and another one is 2 days, whatever. As I said, initially I was starting with 1 node and then increased with another node. Both of them are ready. Now let's go kubectl get pods. Okay. I'll say why all namespaces. I will refer to my commands. Yeah, all namespace. All namespaces. So the point is, the pods, there are too many pods, and I want to show you this. You have Istio installed. You have Kubernetes internal DNS proxies and all that installed. You have, I want to show you the key thing here is service mesh. You see this? This is installed, and you see this Mule service mesh. This came in because of our Anypoint service mesh. All these are pods. All these are pods. So in order to run these pods itself, my entire Kubernetes took 4 CPU. So anyway, let me make this fast. We are short on time. So these are all the pods, and I created only one. All rest are coming from the installation. I created only one, which is this. And for that, to separate them, I put something like Mule API. This is a service. And let's look into the service very quickly. Right, CD, where am I? PWD. I hope my screen is visible. Okay, ls. I created a folder called Hello World Node App. And I created a file called server.js, edit server.js. And I have an editor, wonderful editor here. I could do a VI, but I just want to show you this. And it's simply, this is simply nothing but a simple Node.js Hello World service, right? Come on. Yeah. So as I said, I exposed this. This is a simple Hello World. You make a request and it responds with Hello World. And it basically is listening on the port 8080. And now, obviously, if I kind of, I deployed this into a container image, into Kubernetes container image store. From there, I pulled and deployed into the Kubernetes cluster. Okay. What I mean to say is, you see in this workloads, like we saw, right? This is a cluster. In the workload, I see Hello Node as a deployment. So I deployed this into the Kubernetes. This is very, very simple and easy. Now, deploying is not sufficient. I need to have a service, like I said, right? In order for it to be exposed to the rest of the world, I have this service, Hello World service, which is actually either exposing to the external world or to the internal world. In this case, I've exposed to the external world so that I can show you from a browser, so that it is only, but even if I expose it within the cluster, the policies would work. But for me to show from a browser is easy, so that's why I'm showing you this way, browser or a, else I have to log in into the cluster and show you in the commands that, these policies are being applied. So that is the only reason I expose this to the external load balancer, but I need not expose this, but I could just create a service for internal communication. So this is a service, right? Let me go back to the terminal and I'll just show you most important things. One more minute. I showed you the service. I just want to show you the adapter, okay, that I created. I just say adapter list, shows one adapter, right? And it is ready. And this is of medium size. There is a size for this adapter as well. This is also a pod. So this is the adapter, the Mule adapter that is actually talking to the API. And very importantly, and the last step is something that I want to show you. I created this API, right? Let me show you how to create a new one. So manage an API, create a new API. Okay, let's say sample API 2. I select HTTP API and just say continue. I'll say non-Mule application managed by Anypoint service mesh. I don't give any other detail. Remember, this is what I'm talking. Basic endpoint and non-Mule. You must have never done that. Basic endpoint is always with the Mule most of the times, right? I mean, apart from Anypoint service mesh. So these are the only options. So this is the first time I'm using basic endpoint with a non-Mule application. And this is what I did. And I just said, I'm not giving anything else. And I said, save. Let's say if I save, once I save this, you see I get an API ID. This is what I am now binding by running a command. Okay, I'll show you how I bound. There's a command that you can use, but I'll show you that I bound that sample API already with this adapter that I showed, right? 3ASM adapter. I bound this particular API with that adapter. This is a key step that I want to show. See this? This adapter can take up to 50. I think it is of medium size, so it can take up to 50. If it is a small size, it can take up to 25. It can take up to 50 bindings, and I bound it with a single command. It's very simple. I can run it now also, but this was the API ID of the previous service. Let me show you that. Sorry for the time thing. So you see this 1607215. That's nothing but this. This is how, and this is connected to the Hello Node service, which is the service where I deployed this Hello World application. So that's how I bound it. And the moment I bound it, I've got the complete control in the API manager. I do whatever. See, look at the analytics. I can see what happened in the last few days. I can look at in the Anypoint Exchange. We have already done the policy management using an API manager, so on and so forth. I think that brings an end to this demo. And I'm really sorry for the time, a bit of mismanagement, but that's the demo. We have completed that. And Aaron, what do? We have a fourth question. Do we have any voucher or just let's go ahead with the fourth question?
Yeah, one from Naveen was,
do you think
how
we
do
should
you add the API ID? And you actually just covered that. So I believe that was answered. Naveen asked that one. That's great. I'm just scrolling back up.
Okay.
1 second here. I believe there's one other that I was actually curious about too.
Sure.
Let's see. So service mesh can only be applied to microservices deployed to a Kubernetes cluster. True or false, Sridhar? Okay.
Yes, true. Service mesh can only be applied to the Kubernetes cluster. And that too only be applied if it is one of these three clouds at this moment. Google,
Awesome.
AWS, and Azure. It cannot be applied to the Kubernetes cluster on-premise.
And then the last one I was actually curious about is, are the policies applied in API Manager, are they downloaded to Istio and get applied there, similar to how it actually works when you have a worker deployed to Cloud Hub?
Exactly. You can think that is true. I mean, you can think that way. The policies applied in the API Manager here will be applied to will be connected to the Istio, similar policies in the Istio using the Mule adapter. So Mule adapter is just translating from the API Manager to the Istio. So the API Manager is just connecting to the Istio here. So again, this is something that I want to highlight. You're not doing anything for the application of these policies, right? You're only see, for example, our API gateway, API, when you do the same thing with our Mule APIs in Anypoint Studio and Discover, or in your Mule runtime, you have that policy runtime also, right? In your Mule runtime embedded, which actually works on these policies applied in the control plane. But here, that is not the scenario. Here, you're just trying to see how you talk to Istio and let Istio do its work of applying the policies. You're just igniting Istio by Mule adapter.
Thank you. We had a couple other questions just come in. Custom policies, can they be applied in this use case also?
Oh, no, okay, good question. First of all, let me show you this. There are a lot of limitations to the policies as well. As you can see, let me go very quickly. You see, these are very, very limited policies. If you really, hardly have anything. And I'm surprised by this. This is one of the criticism that I myself have. Are you just saying that all this pain that I take and license costs and all, just to apply this, rate limiting, basic authentication, JWT client enforcement policies, nothing else? Something that I will need to get from the product management. But coming to the custom policy question, I don't think we can apply them, but I'll have to get back. I didn't try myself. Nothing of that sort is told in the documentation. But I'll get back to you on that.
Finally, Akshay is wondering about some limitations with regards to which microservices we can expose using service mesh, and kind of meaning, does he need to tweak his microservice implementation in order to be compliant with service mesh?
Absolutely no need to tweak. As I said, I showed you the Hello World Node.js service that is just, you can see that, right? I was showing you that. I didn't tweak anything, and that's where exactly the service mesh comes into the picture, right? You don't touch the business logic. You already have the sidecar proxy, which is by Istio, which is doing the service mesh features. All I need is a simple 2 commands, one to install the adapter, and the second command is to bind this API to the adapter, and done. And bind this API with this adapter to that service, right? You need to have, when you bind, you need to have a source and a destination. If you bind another API with another service, boom, that's done. Nothing else. You don't need to tweak anything. And that's good.
All right. I think we can wrap up. And Sridhar, if you're all done with the demo, I think Brian will actually take over. Right? Oh, we have one more question, right?
Yeah, probably. I mean, okay. This is not a part of trivia. So you'll not have, you need not type in fast. I don't think you'll get a prize, but just a question. I'll kind of read it out because of lack of time, right? So there is an app written in Python deployed to the Google Kubernetes cluster, similar to the app that I wrote, right, in Node.js, NPM. And the app is publicly accessible, very similar to what I've done there. The C4E team felt a need for bringing this app into Anypoint Exchange for discoverability. What is the best and simple method to do so? Remember, this is publicly accessible. I'll wait for 10 seconds. The first answer is use Anypoint Service Mesh. But again, publicly accessible and best and simple method are the keywords here. Install Service Mesh, connect, do exactly what I've done. Or you can just simply create an API in the API manager with as an endpoint with a proxy, right? And provide this implementation URI. And the other options are not possible. And download the Python app and deploy into the Mule runtime. while you try answering this, the answer would be B. And because remember, this is exposed externally, and any service anywhere in the world, in any platform, sitting anywhere, if it has a publicly accessible DNS, which is what I'm saying here, should be first, explore. If you want to bring that in the MuleSoft Anypoint platform, you simply use API proxy, which is available already today, right? You know this very well. We're just, I don't want to show this again, but this is just an API proxy that you can kind of, when you create the API, you have the proxy there, right? Expose the implementation URI. You don't need service mesh for this. Service mesh is only for if you do not have this externally accessible or exposed. That is when you want to have service mesh, and that's for the east-west traffic. So this is a north-south traffic. Client calling this API. So no need. So answer is B. All right, let me move on. So there are some criticism and comments about the Anypoint service mesh, and I kind of want to openly bring this out. And because these are many of the questions also, Istio still remains actual service mesh. It is not Anypoint service mesh that is bringing the service mesh features like discoverability, application of policies, management, and all. Anypoint service mesh is just connecting to the Istio service mesh. Well, while Istio does it, I've repeated this many times, but this is a key thing. And one needs to understand that, because if your client asks something, oh, you know what, I need service mesh, boom, Anypoint service mesh does everything, is not something that you need to kind of talk to them. Okay, you need to say, you need to have Istio, and only in this case you can connect to the Anypoint service mesh. What we talked about before. Istio already, it just repeats the same thing, right? Istio already provides all these policies. Then why do we need to have API, Anypoint service mesh for the policies? There is some redundancy. Yes, it's not redundancy. API manager connects to Istio's policies and just implements the same thing. And not implements, but it calls those same things. It is not actually implementing them. Now, there are a few other comments for your eyes. As I said, it is only supported in these 3 clusters. You cannot even do it in the local Kubernetes clusters. And you need to have a trial license to even experiment and explore. So that's something that we already passed this information to the product management of Anypoint service mesh. Brian and Aaron helped me there, so they are already looking into this. So that brings to an end. I think, again, sorry for the time mismanagement a bit, here. Over to
Sridhar,
Brian.
So, once again, what's coming up next? Again, if you had any, we aren't in person, so normally we would have pictures with the hashtag MuleSoft Mule Meetup. Again, this is a Denver event, even though it's virtual. Please feel free to send feedback to either myself or Linda Gunn. Most of you also have Aaron's address, so that's fine. If there's some questions that didn't get answered, please send them my way and I'll make sure to respond to you. Our next meetup, our tentative dates are September 23rd. That's a Wednesday, probably 6 or 6:30 Mountain Time. We anticipate both the September and the November meetups to be virtual at this point. We are planning on having Data Weave, so that is going to be Mr. Data Weave himself, Jordan, who's presented in the past. Jordan also did a presentation at MuleSoft Connect, at least in the US, a virtual Connect this year. So Jordan always brings some real cool examples in Data Weave, and I like to call him Mr. Data Weave. So, and then the topic for November 4th, we're open to suggestions. So please send any suggestions out as terms of what you'd like to have for the November session, and that'll wrap it up for this calendar year. So again, thanks everybody for joining, and I will hand it over to Stephanie to, I guess, end it. She's still here.
Still here. Yes, just like Brian said, I don't have too much to add here because I don't want to take too much of your guys' time. But again, thank you guys so much for joining us this evening / this morning, depending on where you are. And we really look forward to seeing you next time.